Algebraic equations. Waves. Whether it is a water wave, a sound wave, or an electromagnetic wave propagating through space, the wavelength times the frequency of any wave is equal to the velocity of that wave. Electromagnetic waves, in a vacuum, always travel at the speed of light, which is 3 times 10 to the 8th meters per second. Nothing can travel faster than the speed of light, and in equations, this speed is usually designated by the letter c. The symbols for wavelength and frequency are also letters, they just happen to be Greek. Wavelength is given by the letter lambda, and frequency is given by the letter nu. The nu looks like an italicized V, so don't confuse this with velocity. You often see this equation written as lambda nu equals c. So what are the units of lambda and nu? Wavelength, lambda, has the units of distance, or meters, and frequency, nu, has the units of hertz, which is just per second. So multiplying together, you get meters per second, which is velocity. Just as with many algebraic equations in a science application, if you know the units of each component, you can often figure out the correct relationships and how you need to combine quantities when solving for an unknown component. As an example, let's find the wavelength of the microwaves being used in your home Wi-Fi network. These electromagnetic waves typically operate at 2.45 gigahertz, the same frequency that your microwave oven uses. Since a giga means a billion, a gigahertz is 10 to the 9th hertz. A hertz can also be written as per second. So how do we calculate the wavelength? We know the velocity of all electromagnetic radiation is equal to 3 times 10 to the 8th meters per second. Somehow, we need to combine frequency and velocity to end up with wavelength. Look at the units. The units for frequency are just per second. Velocity is meters per second. For wavelength, we want to end up with meters. Dividing one term by the other will cancel the per second, but you need to decide if you divide velocity by frequency or frequency by velocity. Note that if the velocity is in the numerator, you will be left with meters for the wavelength. This is what we want. In this example, c over nu is 3 times 10 to the 8th meters per second divided by 2.45 times 10 to the 9th per second, and that equals 0.122 meters, or about 12 centimeters, the size of a compact disc.